Right, 1.3 day number 2, inverse exponential and logarithmic functions continued. Objectives, logarithmic functions, and change of base. It's going to be a pretty brief lesson, so let's jump right into it. Logarithmic functions. For any base b greater than 0 with b not equal to 1, the log function with base b, written like this, log base b of x, is the inverse of the exponential function. Okay, so let's call this f of x. Its inverse would be b to the x power. The inverse of the natural exponential function with base e. So here's our natural exponential function is the natural log of x, which has a base of e. How do the domain and range compare between exponential and logarithmic functions? Make a sketch. Okay. So let's sketch. How about e to the x? Here's e to the x. And the natural log of x there. So the domain and range, seeing that these two are inverses and are a reflection over the line y equals x, the domain and range of e to the x, domain is all real numbers, and the range is from 0 to infinity. All right. For its inverse, domain and range are switched. So the domain is from 0 to infinity, not including 0, and the range is all real numbers. Okay, let's get to some properties of logs. Actually, this same concept applies to exponentials with any base, as long as that base is positive and not equal to 1. Log rules. Just some basic log rules with logs. If we have multiplication, that means that we have addition. So this would be log base b of x plus log base b of y. Basic there. Log base b of 1, doesn't matter what b is, that will be 0. Log base b of b will be 1. Log base b of x will be x. Division. Division similar to multiplication, yet different. Holds a rule of subtraction when you divide. This is a very useful property right here that comes up a lot with a natural log, which you'll see as we go through our course, but you can bring that exponent inside and bring it down in front. As long as b, the base of this exponential function, and the base of that logarithmic function are the same, this will reduce to whatever the argument is on the inside. And then log base b of 1 over y would be the same as log base b of y to the negative 1, which would be the same as negative 1 times log base b of y. A couple of shortcut properties that'll come in handy later. Change of base formula. Change of base formula, I'm not going to do the proof, but the change of base formula can be important. If I want to write this logarithm in base b form, I can write it as the division of two logs, both base b. And those arguments come out to be those values, the original log's argument over the original log's base. Okay, just a shortcut to be aware of. All right, let's continue. Solving. Let's do a little bit of solving. I'm going to pause the video, do the first 3, and come back and see how you did. Okay, so for A, B, and C, it looks like all of that I did was I put them into exponential form and then did a simplification if necessary. So I get 3, I get 1/9, and I get e to the 5th. I didn't reduce or simplify e to the 5th by getting a decimal value and rounding. It's not necessary at this point. Okay, how about the next 4? I'm going to pause the video, go ahead and attempt those, and come back and take a look. Okay, part D, x cubed equals 8, so x equals 2. Part E, writing that in logarithmic form, I get log base 5 of 18 equals x. Can't go any further without a calculator. F, log base 8 of 17 equals x plus 2. I subtract 2 from both sides, I get x isolated. And part G, not the greatest color selection. But that would be, looks like, I could write that in multiple forms. But I'd have log base 2 of 10 minus 7 over negative 3. Okay, let's look at a couple AP style questions using just wording and our knowledge of exponential and other functions. We want to range from 0 to infinity. Well, right away, I know that this is out. I know that this is out just due to the graphs. I know that the natural log goes to negative infinity as it gets closer to 0. Tangent, it goes to negative infinity as it approaches negative pi over 2. X squared plus 1 is tempting, but the range on x squared plus 1 would be a parabola that opens up, but its min value is at 1, so that's out. So we've got these two. So A, absolutely, definitely, it's a parabola, opens upward, centered at 0, with a min value of 0. Ooh, actually, that's out too. Why? Because that would equal, right? That would require that to equal 0, so that's out. So the only value that will work here looks like e to the negative 2x. Now, what that will look like is because that exponent is negative, it's going to approach 0 as it goes to the right. So as x approaches infinity, y would approach 0. Okay, last question of the notes. If you want to, you can pause the video right now. Otherwise, I'm going to roll right through it. Let's do this. Let's go purple. Okay, so 6e to the 2ln of 4. We got some properties going on here. Plus 3. It's a little ambiguous. You're not quite sure. Should I put parentheses around the 4 plus 3 or just the 4? If there's no parentheses, assume that the 4 is the argument. Right? Okay, so here we go. We're going to do some manipulation. First thing I'm going to do is I'm going to take that 2 and bring it up as 4 to the second. Right? I'm going to make that a 16. All right, and the other thing I'm going to do is, I'll do that in the next step. So now what I'm going to do is, I think we can agree that e to the x plus y is equal to e to the x times e to the y. So if I have e to the ln of 16 plus 3, that's the same as e to the ln of 16 times e to the 3. Now this is another property embedded right here. This base e right here is the same as the base of the logarithm, so this would reduce to 16. And 16 times 6, I believe, is 96. Let's see if we got a possible answer here. Yep, we got a match. Looks like our answer is A. All right, that is 1.3, day number 2. Peace out. See you another day.